Hello.
Hi. Hello,
Yet
everyone.
another.
Yeah. Hi, everyone who's here. Welcome to yet another You Choose. This is a Choose Your Own Adventure style show where we're navigating our way through the entire CNCF landscape. So we're in Chapter 1, Episode 5 already. Time flies.
Out of how many? 150 approximately?
Well, we're in Chapter 1, there are 7, and I'm only thinking about that because if I think about all of it, I'll just quit. I'll just fall over right now. One thing we were talking about pre-show is celebrities that, like, you know how everyone has like a celebrity lookalike or people have a celebrity lookalike? You told me who people told you they remind you of, and it made me fall over from laughing.
All the guys on a balcony in Muppet Show. those who all they do is complain about what others are doing. And it's extremely satisfying, right?
It's so you.
Yeah.
I love it so much.
But I do go to some talks in conferences. I'm that guy in the first row, kind of. And then I'm not even paying attention to what the presenter is saying, kind of like, okay, so how can I mess up with him, kind of like, okay, what will make him really freak out on the stage? That's me.
Or her. I know you've been to a couple of my talks. I'm glad you were kind to me. I didn't appreciate the bullet that I dodged. Now we're going to present together at KubeCon, so maybe I won't get heckled if we're on stage together, or maybe it'll be twice as bad. I'm not sure.
You mean that excuses you from the process? Okay.
It's fine. I'm not afraid. I ain't afraid of you. Okay, so we're in Chapter 1, as we said. We're in Episode 5. I'm going to very briefly recap what we've been through so far. Victor, stay with me here. So Episode 1, build container image. Y'all chose cloud native build packs. Episode 2, push that image to a registry. Y'all chose Harbor for that. Episode 3, define your application with and y'all chose Carvel YTT for that. Last episode was use HTTPS. And what were our choices there?
What did they choose?
You actually didn't choose anything because you didn't have a choice. It was you don't choose last week because Cert Manager is the CNCF offering for managing certificates with Kubernetes. We should probably. What did you learn last week about Cert Manager, Victor?
I learned nothing in general ever.
No. Then how do you know anything?
I don't. I'm just very good at pretending. You know, it's same thing. Like, a long time ago when I worked in an office, right, everybody watches football. I'm the only one not watching, but I still engage into conversation. The arbiter was obviously favoring the other team. Kind of like, that was obviously happening. Kind of, and there was a penalty. Yeah. Oh, no. Oh, yeah. That was a clear violation. It always works. You don't have to watch football to know kind of how
I'm
to comment.
outraged. Yeah.
Even if your team won and you don't know, you're still outraged because we could do so much better.
So the answer to pretending like you know everything is just to be angry at everything all the time.
Exactly.
Oh, I'm doing it wrong. I'm like taking the time to really learn stuff and trying to be nice. It's a lot of extra work. Speaking of,
it's a rookie mistake.
Clearly. So Cert Manager is super awesome. You can define a certificate resource in Kubernetes. So you say, hey, I want a certificate. You point out an issuer, which is another resource that you can define in Kubernetes using Cert Manager. And a resource ties Cert Manager to an actual certificate authority that exists in the world. So you say, hey, I want a certificate. I want it from this issuer. So I want it from this CA. And then I want it to live in this particular namespace. And then Cert Manager magically behind the scenes makes that certificate, puts it in a secret in your namespace, and then it will automatically renew that certificate as specified by the issuer. And once you make that certificate or resource, you just set it and forget it. But there's a lot of
Exactly.
amazing stuff happening behind the scenes to make that happen.
You don't care. You just get certificates and that's it. It just works.
You might be a professional certificate nerd like Ashley, who was on our show, and that's okay.
Yeah.
You can
me too.
care.
There are certificates nerds, 3 in total, probably. One of those 3 is going to retire soon, so we're going to... Ashley will be 50% of them, yeah.
That's amazing. I think we came up with a video game premise where one of the trust dossiers, one of the keys gets compromised, the keys of power, and you have to be a professional certificate nerd and go rescue the compromised key. We're so much fun here. Ugh. I say with rolling eyes. I hear myself talking. Anyway, so that's what we did last week, and now I think it's maybe time for you to show us how to implement that certificate resource that we were just talking about.
Yeah,
what do you think?
That's
you
what
ready?
I'm going to do right now. Can you put my screen on?
Yes. There we are.
Okay. So since we are using YTT, that was one of the previous choices. I implemented it in YTT. A couple of resources here that matter. First is Ingress. And you will see here if TLS is enabled, which I'm going to do soon. I'm selecting the cluster issuer should be called production. I already set up Cert Manager in advance. There is a cluster issuer called production already running in a cluster. And now I'm instructing my Ingress to use that cluster issuer, right? In YTT format. And another thing would be YTT resources and certificate. This is the certificate itself that we are requesting. We are requesting it using cluster issuer production certificate. And here we are specifying the host and the DNS, which is same as the host. For that certificate. So essentially we are telling it what is the domain, the host that it should get certificate for. And finally, you saw some values there. So here is the schema of YTT. Doesn't matter. What does matter is that TLS is by default disabled, right? So I'm going to enable TLS in my manifest. There we go. I changed TLS to be true, and I'm going to generate manifest first. YTT -- file, YTT schema, and another file which is YTT resources, and another the values file for my development environment, which is values dev, right? And I'm going to output that into BitT into YTT dev. Why it doesn't work? YTT. What's the directory? I forgot. No, not YTT. YAML dev. This is where I keep stuff. Up YAML, and there we go. Right. I got Ingress with the label required. And I got the certificate now. This is new. This was not happening in the past. So let me deploy kubectl namespace is dev. I want to apply whatever is defined in YAML dev directory. Let's go. There we go. The certificate was created. The ingress was modified or configured. Now, to be on the safe side, I'm going to output issuer, certificate requests, certificates, orders, and secrets, because certificate will be in a secret ultimately. And not there yet. It did not create yet what I need. So we need to wait for a second. Let's try again. Still not there. Sometimes demos failed. We'll see.
I have a question. So you used an issuer, a prod issuer. Is it common for people to use HTTPS for a dev environment, or is that something?
I don't think it's that common, but there is no good reason not to use it if it's because I'm using now Cert Manager with Let's Encrypt, gives you certificates for free. So if it's free, if it's no additional work required, the better question would be, what's the reason not to use it, right? And still not working. I'm going to double check what's going on. And if it doesn't work, then I'm going to blame it on Whitney.
It is probably my fault. Or
Exactly. There we go. It's still not there. I'm not sure why. Probably because before the show I was messing up with the cluster. I shouldn't. We'll get back to it later. Imagine that it worked and we would get a certificate and I could visit my application right now. Actually, there it is. It is working.
It is.
There we go. It came at the last second. You know it's working because I know it's low resolution, but you can see here information that connection is secure. It's using HTTPS. It's working. It's there. Rejoice.
Woo! Boo, 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 boo! Air horn. Okay.
There we go. And that's all you need to know. And it's really easy. You just specify, let me remove this. You just specify the issuer you want to use. And that's about it.
And like the domain
label in
name?
Ingress.
Yeah, and the domain name you want to make your,
Exactly,
secure.
yeah. Domain name is kind of important, otherwise. Not good. Now, you can use Cert Manager also for internal traffic, for internal certificates. We're not doing that today. We're going to get there, nobody knows when. Within those 190 projects left.
If you and I don't know, we can safely say no one knows. All right, so today we have, we're not going to introduce our guests just yet. We're going to talk about them a while first. But we have Dan Magnum coming from Crossplane and Andy Block from Helm, who Dan and Andy, I'll collectively refer to them as Dandy. Yeah? No? Okay. And so I'm super excited. They're each maintainers, and they're going to teach us about this next step we want to do, which is to set up PostgreSQL database in our development environment. So
Exactly.
Yeah, what are we thinking about as we review these technologies to use for this step? Like what are we evaluating when we're looking at them?
So essentially the choice is really, ignoring now with which technology we're going to accomplish that, the choice is really, Ben speaking about development environments specifically, whether to run Postgres, in our case, locally. And when I say locally, I don't mean your laptop. I mean the Kubernetes cluster where the application is running, or to use one of the cloud vendors, Google Cloud, Azure, AWS, Alibaba. I don't know what else is there.
So why would you choose to run through a cloud vendor as opposed to spinning one up in the same cluster as your application?
So with cloud, it's generally speaking, ignoring that it's development environment, I like the idea, not my problem. That's my life philosophy. Meaning, hey, it's running in AWS, Azure, Google. They know what they're doing. I have my database. I create it when I need it. I destroy when I don't. Now, potential problem in development environments for that is that it might take time. And when I say time, depends on the vendors, anything between 1 or 2 minutes to maybe 10 minutes to set it up. If it's running locally, then that should probably be reduced to seconds, below a minute.
So to run it locally has a lower time cost and probably a lower actual physical money cost too.
Yes.
Yeah.
Again, depends, if it's something short-lived, then, you're going to run it while developing, testing what's or not. We're talking about hours. That doesn't cost in either case, right? And we're talking about small instances and things like that. I don't think that cost is a major, when you have petabytes of data, then that's an issue, right? That's a cost now for a small database. if somebody has an issue, I'll wire you $3 and you have a month of a small database or something like that. I think that the bigger issue is really not issue, but patience, right? Is 10 minutes too long or too short? And also, some people, for one reason or another, do not want to or cannot use cloud, right? And then running it in Kubernetes cluster is definitely the option.
Okay. So is that the main thing we're thinking about when we're looking at the tech today, or is there other factors we should be considering?
That's the main thing. How can we spin up a database in development environment, whatever the development environment is, whether it's a local cluster, remote cluster, some cluster.
All right. Is it time to bring on our guest just to say hello?
Yes.
Bring on Dandy. Let's bring Dandy onto the screen. All right. We'll start with Dan Magnum. Welcome, Dan. Introduce yourself, please.
Hey, folks. My name is Dan. I go by #Dan on all the places. I'm a Crossplane maintainer. I work with Victor at a company called Upbound, and very honored to be here today. And I love the setup of this show. I especially love the logo. I was going to ask y'all, did y'all get that made, or where is that from?
I made it. I drew that up. I drew all those silly graphics. Thank you.
That is amazing. Love it.
I was in my degree's in fine art. It's
awesome.
But that's I switched. Yeah. Thanks for the compliment. How do you make this about me? This is about you, Dan. Don't turn this around on me.
I can make it about Dan if you want to. Dan, increase the volume of your mic.
Yes, please do that, Dan.
All right.
Thank you.
Is it better now?
Yes.
Better? Okay, cool.
Perfect. All right, and now Andrew, welcome again. Andrew's back to teach us about Helm.
I didn't scare you all away. Thank you for inviting me back.
Didn't we establish a time the one scaring people? Now are you becoming a competition? There's room only for one scary person here.
Yep.
He's scaring you about scaring things. It's like meta.
Maybe.
Thanks for being here, Andy. Will you introduce yourself, please?
Yep. So, hey everyone, my name is Andy Block. I'm a distinguished architect at Red Hat. I am also a maintainer on the Helm project, so I do a lot of work in the upstream community, everything from Helm, OCI integration, and just doing a lot of things, all things Kubernetes. So, really happy to be back in the saddle again.
Excellent. So glad to have you. Okay, Dan, we're going to hide you away and let Andrew do his 5-minute presentation. So we'll see you shortly. And actually, in very close to 5 minutes, because Victor's going to make sure this is very... Victor loves this power. Bye, Dan.
In the pre-call, Victor is very clear on 5 minutes. So I'm going to find myself too, so I don't go with it.
Andy, though, your screen, I don't see where your screen is shared. It seems to be gone. Will you?
It's not. I have not shared it yet. I'm going to share it now.
Excellent.
All right.
Go.
All right.
Cool. So let me go ahead and let me start the recording or start the timer, and here we go. So since I'm a maintainer on the Helm project, I'm going to talk about using Helm to set up the PostgreSQL database in a dev environment. So for those of you who do not know, Helm is a package manager for Kubernetes. It allows you to easily define and package your applications in a simple way that is very common to thinking, at least, of how you typically define applications in a non-Kubernetes environment. Think of it similar to Yum, DNF, apt-get. It has all of the dependencies, all of the application manifests, and all the resources that you need for your application. It is a CNCF project. It's been a CNCF project for, oh my goodness, 7 years, or joined in 2016 and graduated in 2020, and has a very high and active contribution base, everything from 13,000 contributors, 1,700 companies, and that number probably is not even close to being accurate these days, 9,500 code commits. It is popular. The primary components of Helm are, first, it is a CLI tool. Basically, everything you do is through the Helm CLI. A Helm chart, or Helm package basically, is a chart which defines a set of Kubernetes manifests. Inside this chart are two primary components: templates, which are basically dynamic resources for Kubernetes. Everything from your typical Kubernetes deployments, services, ingresses can be templatized. And those templates are combined with properties called values. So think of it as whatever we take from a value and a template becomes a Kubernetes resource. And then when you deploy those resources in a Kubernetes environment, they then become a revision. It is basically a snapshot in time to a chart at a particular point within a Kubernetes environment. And this next diagram really shows that combination of the Helm chart combining with values using the Helm CLI to then become a release within a Kubernetes environment. Everything from deployments, pods, custom resource definitions, services, all can be defined within a Helm chart. We can deploy many different types of applications with Helm. We can deploy simple microservices, we can deploy traditional monoliths, or legacy monoliths, pardon me, or even databases, everything from NoSQL to relational databases like Postgres. You can also do dependency management. So you can have applications and charts depend on one another. A good use case is, for this use case we have here in the You Choose series, an application. So I may have a dependency on a database because I always want to have a database be easily deployed with my application. I can go ahead and define a relationship between one or more charts. And you can even go into more full lifecycling from Helm. So a great use case of that is with the database, you may have some scripts that you may need to run to maybe populate the database with some schema definitions or just data itself. And Helm supports that fully by configuring the different manifests that you define as part of your Helm chart. And then there are different points in the Helm lifecycle of when you can create these hooks, everything from before it's installed, before it's deleted. So if you want, you can do some cleanup process. If you need to do some upgrade to your chart, you can then run an upgrade script and commands, all easily configurable with Helm. If you want to learn more about how to get up to speed, getting up to speed is really easy with Helm. First, install the Helm CLI. If you want to go ahead and deploy a database, for example, let's just say Postgres, you can add a chart repository, a chart where a chart may be defined in an upstream location. You can then quickly install the chart, and then you can also use it as a dependency. And that's it. Let's talk about the 3 use cases we have here in the 1 minute we have left. First case is I want to deploy a simple Postgres database to my cluster. I can run the Helm upgrade, give it a name, which is simple Postgres. Bitnami provides a great Helm chart for us to use. We can just go ahead and quickly deploy that.
We make it bigger, please.
You can make both bigger. It's going to quickly deploy that Helm chart. Give it a second. Gotta love. This is taking a little slower than I would have hoped. Running. Okay, perfect. Just like that, we have a Postgres database running. It's got storage. I can then go ahead and deploy one without storage. I know I'm running low on time, so I'm going to go ahead and just quickly deploy one without storage. Oh, it's now gone off on my side. Give it a second. All right, it's gone ahead and installed, as you see here.
Great job. Wonderful work. Good job. It's a lovely presentation.
Almost there. I know we're almost there.
It's your screen's gone, friends, but it was. I'm so sure that it was going to work. Is that a mic drop? I love it.
It was.
Great presentation. Good job. Thank you so very much. And we're going to put you in the back, but if you have any questions, please do put them in the chat, and we're going to do a Q&A section after this part of the show. So if you have any questions for Andy, please put them in the chat. And here we are, Dan. Teach us about Crossplane, please.
All right, I'm hitting start in 3, 2, one. I want to make sure I'm aligned here. All right.
Wait,
so
your screen's not on the. Hold on.
I think y'all got to
There
pop
we
it
go.
There
Okay.
we go. All right. So I'm not going to try and do the live demo, but we'll talk through a variety of different ways we could do this with Crossplane. I will note kind of up front that we're cheating a little bit because we're also using Helm as part of our setup here. So I'm going to go through a little bit of what Crossplane is, if I can get the slide to advance here, in 2 minutes or less, and I'm already 30 seconds in, so we really need to get running here. All right, so the first thing that Crossplane is a way to interact with any API via Kubernetes that includes APIs outside of a cluster. So Crossplane provider packages, which are one of the 2 types of current Crossplane packages, will install CRDs and their corresponding controllers into Kubernetes clusters. They're opinionated OCI images, which have a format that specify this and make sure that only one controller is reconciling a given type defined by a CRD. You can see an example here of provider AWS. It has 872 CRDs. They have lots of APIs over there at AWS. You install this, you get access to all those APIs as Kubernetes objects in your cluster. You can also build abstractions with Crossplane through a model called composition, and it maps higher level APIs that you may define. You can think of them as interfaces to one or more implementations. So if we want to think of an example that's pertinent to the project we have here in this series, is we might define a database API that is implemented by maybe a Postgres Helm chart, maybe a Cloud SQL instance on GCP, and maybe an RDS instance on AWS. And depending the context in which we create that database or provision it, we'll select one of those options. So you can also take these abstract APIs, package them up into the second type of Crossplane package, which is called a configuration. They take these higher level APIs, define their dependencies, kind of like Andrew was talking about there with Helm dependencies. And when you install a configuration, Crossplane automatically resolves those dependencies and make sure that everything is good to go. You can also use configuration packages as the foundation for future APIs as well. So composition is something that you can nest and build higher level APIs on top of. If you want a nice parallel of what we're trying to do here as you're building a platform with Crossplane, is you can think about AWS. Lots of AWS's managed services run on AWS itself. They're kind of built on these foundations of EC2 and S3 and some of these more primitive APIs, which allows them to implement higher level APIs on top. So we're doing a similar thing here. So you have to make your choice, right? You have to define whether we're going to use Helm or we're going to use Crossplane. And like I said, we're going to use a bit of both here. But what you're getting from Crossplane is enabling tomorrow's evolution, right? Our platform is going to grow and evolve. We want a dev database now, but we may want something else in the future. And we want to do that without introducing complexity today, right? We want a quick experience for provisioning this database locally, maybe not having to pay much, even though Victor has volunteered to foot the bill here. We still want to avoid paying for that cloud service, maybe when we're just iterating locally. So we have a few steps for what we're going to do. First, we're going to pick a database API. So when you or developers within your organization are deciding what they need to configure on a database, you want to expose just those fields for them and not expose any complexity that they don't need. Second, you need to pick an initial implementation. We could use the Bitnami Postgres Helm chart here, which is offered by provider Helm, and just say, hey, when someone creates my concept of a database, this higher level API, we're actually just going to deploy that Postgres Helm chart in the same cluster where they're deploying their application. So really simple implementation here. Then we can bundle that up into a configuration package, which can define that dependency on provider Helm, which means that you just have to install one thing and Crossplane will make sure to do the rest. So last thing you do, provision that database, author that very simple manifest. We'll call it myCoolDB here. Crossplane's going to say, hey, I know when a database gets created, the only implementation we have here is this Bitnami Helm chart. So I'm going to create a Helm release in the same cluster. Great, our local dev experience is going well. But your use case is inevitably going to evolve over time. Maybe in chapter 2 of this series, you want a production-ready application that you're deploying. And Crossplane is going to allow you to do that seamlessly by adding another implementation. Here we're using provider GCP to offer Cloud SQL, and we can just add that and provision via the same exact API. So from a developer experience perspective, nothing changes for you except for where your provisioning gets scheduled to. And with that, I'm done 15 seconds early, and Victor does not get to shake the phone at me.
You got the last laugh in the end. You figured out how to punish Victor.
I don't get to enjoy this at all. Not fair.
Rude.
My job at Upbound is actually just to make Victor's life harder. So mission accomplished here.
You're doing great work. That was still a stellar presentation, even though I didn't get to tell you in an interrupting fashion. Thank you so much for sharing your expertise with us. I'm going to bring Andy back so we have the full Dandy experience, and we're going to get at your questions. Also, I'm seeing in the chat, give us your questions too, that someone suggested that you buy a gong, Victor, and get a shepherd's crook so you could really be like the Muppet guys. And then you said that you really did buy a gong. Is that true?
While Dan was speaking, I went to Amazon Prime. Delivery, it comes tomorrow. It will be available for next episode.
Well, is everyone familiar with the Gong Show? I mean, that's what it's really what it's from. It's the Gong Show.
I had forgotten. But also, I could just see you, Victor, now with every like internal meeting you go to, when you go talk to potential clients, you're just gonna be armed with that gong. If anyone goes on too long about anything, it's okay.
Great suggestion. Everybody in my building is going to hate you, Mark.
All right. So we have a question that is just about, is cloud native PG. Do you mean Postgres when you say PG, part of the CNCF landscape?
Not that I know. So Postgres in any format is not part of CNCF. And many choices that we have here is not 100% CNCF, but there is a CNCF component here, right? So we can run that Postgres with Helm, which is CNCF, or with Crossplane, which is CNCF. It could be in cloud, which is not CNCF, but still Crossplane or Helm. So short answer, not CNCF, Postgres itself.
We have very loose boundaries around these parts. So definitely with that, like not every project we touch is CNCF, although we will rule out some things because they're not CNCF because we have to draw lines somewhere. But and then like this episode is actually a perfect example. They're not mutually exclusive technologies. Like if we implement Crossplane, there's a good chance we'll be also using Helm versus if we implement vanilla Helm.
Actually, if we choose Crossplane, it's the other way around as well. If you choose Crossplane, then Crossplane claims will be packaged together with your applications in Helm, right? So
yeah, I have definitely seen the taking that database API, putting that as part of your application Helm chart there, and then that actually flows through. And sometimes, right, if it's local dev, right, it will create another Helm release for the Postgres database there. And then if it's more production scenario, it will create, something on GCP or AWS.
So we're going to have to be really explicit about what we're voting for exactly when we have these choices.
I mean, the key thing here is we're talking development, right? Like something like Helm, boom, 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 done. Getting something out there versus I have to go ahead and install an operator, have that available, define additional capabilities. We're talking just on the development side. I can know that very few developers want to deal with all that just to get something running. However, I still say, Crossplane, great if we're actually rolling this out to higher level environments, but if we're just talking development, it's a lot to put on the developer.
Well, the nice thing is, if you have this packaged up, and we have some configuration packages you can check out in the Upbound Marketplace. Don't come for me for the self-promotion there. But if you want to install that, we're going to get those operators installed automatically for you. You won't even know the difference.
Who says you have access to install the operator?
Say it again? Who
says you have access to install the operator or the CRDs?
Well, they're just OCI images, so shouldn't be an issue. Crossplane installs the CRDs on your behalf.
Do you have permission to install it?
Absolutely. Do you have permission to install the Helm chart?
Yes, you usually.
I think that you're talking about different things.
You're getting
a tenant model.
It's a tenant model. You only have access to your namespace. You don't have cluster resources. How can you install the CRDs?
If you have access to install Crossplane packages, then you don't have to install CRDs. So you could give access to your developers, but typically it's going to be an operator. If you have a local cluster that you're running, I assume that you're able to install things at the cluster scope. That would be some artificial constraining yourself, but perhaps maybe.
I'm going to get to a question from the chat. Does Andy recommend Helm even for our own application packaging, or just continue to use old school deployment YAML files?
Always recommend some type of packaging solution whatsoever, whether it be, we talked about in episode 3, Helm, YTT, you name it. Always give yourself some type of packaging solution, and more importantly, make sure they're all managed via GitOps.
Excellent. Which we'll get to in chapter 2. We have another question. Is there some example document for Crossplane to deploy Postgres with Crossplane, even though it's a Helm chart?
Okay, so it's for me. Yes, I have a configuration that I use often in demos and talks and stuff like that, that contains Postgres running locally in the same cluster or in any cloud, like 5, 6, 7 variations of that. If you go to marketplace.upbound.io and search for DOT, like short for DevOps Toolkit, you will find my configurations, and SQL is one of them.
We have a question from Mason and a lot of response from others in the chat. How are we dealing with persistent database storage when deploying to an on-prem cluster?
That's easy because it depends on the type of storage that your cluster provides. It can be, if you're like in a VMware environment, you can do typical VMDK-based storage. If you want to use object storage in certain cases, you can use that. There are plenty of different options out there. It just depends on what's available in your cluster.
I mean, typically, by the time you get to that point to deploy the database, there will be at least one storage class, potentially more. You just need to choose which storage classes are available, right?
Yep, you just define the storage classes that are available in your environment, and you can be local volumes if you have access to those as well. It's up to you.
And we have a comment from Zigglefingers, Rook. Yes.
Rook also works as well. Rook is a great CNCF project that allows you to provision storage.
Okay.
We have another question. A good question. Crossplane can also be used for on-prem bare metal Kubernetes clusters?
Absolutely. So if you want to do something in cluster, right, that Helm chart case we were talking about, or you could use provider Kubernetes, target Kubernetes directly, or, if you want to reach out from your on-prem bare metal cluster to a cloud provider, or maybe to an internal database API that you have, those can also be enabled as well.
Cool. That's a great question. Thank you for asking it. So that's all the questions.
Type questions.
This is a good opportunity for either of y'all to plug something about your technology that you didn't get to say in your demo, if you have anything like that.
I'd love to just bring up a new feature that came out in the latest Crossplane release called composition functions. So Crossplane has a pretty simple mapping language, if you will, all just defined in YAML. It's basically just patches from the abstraction to the granular resources. So if you say a database to an RDS instance, right, you're exposing a simplified API. You're going to take some of those values and map them onto configuration values for your RDS instance, and maybe some network primitive, IAM roles, that sort of thing. That is really nice. We intentionally want to limit what you can do there, right? Because we don't want an explosion of configuration language or a domain-specific language there. So sometimes, though, things get a little more complex, or you may need to talk to an external system to decide how you actually resolve what gets created in response to that abstract API. So composition functions are basically a way to take a containerized image and run it in response to the creation of the abstract API instance and do really whatever you want in there. And so those are a new alpha feature in Crossplane. They can be enabled with a flag. There's also a guide in our documentation. Really opens up a lot of new possibilities for folks who want to do a little more custom stuff in their package building there.
Super cool. I'm hearing some talk of developer experience, and I see with Andy's point that it can be difficult to install Crossplane into the cluster in the first place for a developer. But then it seems like, Dan, with you, you're talking about taking complex resources and providing a really simplified developer interface to make the developer experience good too. So I would love to hear, maybe, I don't know how well I summarized each of your arguments, but I have maybe like a quick synopsis from each of you about what an app team's experience is dealing with your technology. Someone who's not an ops person.
Yes. So from my perspective, I work with a lot of enterprise customers, and they don't run Kubernetes locally. They're usually running on a shared environment. So they are limited about what they can and can't do. They have access to basically one or more namespaces. So being able to operate at a namespace level is basically their entire purview. And then being able to leverage a tool like Helm, you can also integrate that into a CI/CD tool like, Tecton, Jenkins, GitHub, GitLab. You take your pick. There's very little that needs to be done from their side. They can either take an existing Helm chart that might be provided by their platform team, inject that into their application, and they're done.
Got it.
That's really interesting to hear. The what I hear there is a Helm chart provided by their platform team. So their platform team is kind of curating things offline. What we say instead in the Crossplane world is that the API you interact with in your Kubernetes namespace should be curated by your platform team. So in Crossplane, when you're putting these packages together and authoring these abstractions, you're exposing to developers what they have the ability to create. So it's almost like if you went to AWS and you only got the list of APIs that you were able to interact with, but instead they're your platform defined ones. So when you set up that cluster, if you install maybe some things like Prometheus, right, or you install a service mesh or something like that, just standard things which define what a cluster means for your enterprise organization, then you're also defining your infrastructure APIs, and then your developers just take those and they put them in their application Helm charts if they want to, or if they're using a different technology. Once again, it's back to just Kubernetes manifest. So anything you can do with Kubernetes objects, you can do with Crossplane. So if you want to stick them in that Helm chart, or you want to put them in Argo CD, or you want to deploy a Helm chart with Argo CD, those are all available to you.
Cool. That was really helpful. Thank you both. We have a question from earlier that I missed. This seems to do with Crossplane. How to do a local GitOps CI/CD with Minikube and Argo CD to do a quick development workflow and refresh Kubernetes deployments with the latest Docker image builds. And how does that work with, I guess, both Helm and Crossplane?
So with Helm, it's very easy. It depends on if you tag your images using SHAs or just regular tags. You just update your values file, or you can do that dynamically as part of your pipeline. And as soon as that gets rolled out, the change is detected by Kubernetes, and it will roll out the new image. Done.
Yeah, and same thing if you're deploying your application and consuming Kubernetes or Crossplane defined APIs in it, you can once again just roll in that way. If you're actually updating your platform APIs, right? So there's two sides to this, right? The operator, where you're deciding what's exposed as an API, and the app developer, where you're consuming it. If you're the operator, once again, we just use OCI images as well, so you can just bump that version. And Crossplane will also make sure that any dependencies or anything like that are compatible as well, and those will just roll forward. Those are defined as Kubernetes objects as well, the provider and configuration types in core Crossplane.
I have a different opinion on that subject, Argo CD, local, and things like that. And that opinion, short version is don't.
It's going to be much more complex for you. Just keep it simple, especially in development, and just run with it.
Exactly. I mean, and I need to stress the word local over there, right? There is a great value, and Andrew, I think you mentioned as well, to use actually remote environments. You have a cluster managed by somebody, and you develop there. And then Argo CD and all the other stuff makes a lot of sense, right? Because it's already there. But setting up those things, doesn't matter whether it's Argo CD, or it's Crossplane, or it's Argo workflows, or service mesh, you don't want to do that locally. Just bare minimum kubectl apply, or Helm install, or whatever you're using. Push information. Do not do GitOps locally. It's not
the hardest part is, in a lot of organizations I work with, is actually getting resources that can run Kubernetes locally. That's the hardest part. So you're basically just limited that I can only use remote instances.
I have a hard one on that one. If that's the case, you should change the company.
Quit your job. Go find something else to work.
So Victor, you're saying you and I need to go ahead and start a new company that basically goes and changes the company's culture. Okay, gotcha.
We can call it Dandy Incorporated. I'll weigh in on this too. So.
We also are going to do an episode 2 episodes from now, I believe, that's going to talk about developing in Kubernetes and how to improve the actual like inner development loop when you're developing applications in Kubernetes. Yeah,
It's coming.
it's coming. We have another question here. Apologize for so many questions. Don't apologize. Crossplane seems interesting. How, as a beginner, can we learn about it? Like, where's a good place to start learning all these Crossplane concepts?
Yeah, well, I'm sure Victor's videos are a great place to start. I will just plug that we also release a redesigned docs site for Crossplane as part of the latest release, which has a lot of information there, some reorganization, some nice search, and that sort of thing. So definitely would encourage folks to jump in there. And then there's plenty of KubeCon talks, and then all of Victor's content is also a good place to get started.
So this DevOps Toolkit YouTube channel you're watching right now will have a lot of Crossplane information for you. And what are there any caveats or limitations for Crossplane?
Oh, and I'm called specifically. I was about
Yeah.
to throw it to Dan, but now so depends really what you compare it with, right? There are quite a few advantages. There are of course some caveats, or I cannot pronounce that word. My English is horrible. Anyways, probably biggest one would be, and this is intentional by design, that the syntax for creating compositions is limited. That's by design, but it could be limiting to some, partly mitigated with functions. And also, and somebody might throw stones at me, right? It's not necessarily for local development. You want to go to a real cluster where things are set up, right? I would call those two. When I say local development, I mean your laptop, not cluster you connect to.
And then with Crossplane, you have to use Kubernetes. It's both of these are Kubernetes only.
They're both
tools.
Kubernetes.
Yeah.
What else? I mean, now
whole world is
we
Kubernetes.
can create a new series about projects in Mesos if somebody's really interested.
Victor will be solo hosting that one.
So if I ever see Mesos again, I'm going to open a window and jump. And I'm on a 3rd floor. It won't be pretty.
Let's maybe talk about this choice of like Postgres running in your cluster versus Postgres running in the cloud, and which might be preferable and why.
So the cloud, obviously, you're going to have additional costs versus running Kubernetes. That's the big one. The limitation of running Postgres in, is whether if you need what kind of storage you need behind it. In most of the cases, you can run a clustered instance of Postgres, so they each require single write, single read, which is available in most cloud providers. The issue is if you are ever going to use shared storage in the cloud provider, it's not as easy to get shared storage.
Yeah,
That means that Dan is going to defend cloud,
sure,
not by
sure.
choice.
There's everything that Andrew said there. I would plus one. As Victor said, a lot of times I'll actually use cloud even when I'm running things locally, applications on my on a kind cluster or something like that locally, just for the ease of setup, or if I want to leave it running while I recycle a kind cluster or something like that. I'll just keep that dev database up there or something. But same limitations apply as Andrew mentioned, and that's why at Crossplane we want to enable both of those use cases.
We have this, not a question, but an opinion, and I think a good one. For learning new tools, being able to try things out locally is far less expensive, so not sold on always doing things remotely. Thumbs up.
I'm cheap. I'm sorry.
We have an off-topic question, but I think since we're running out of time, I'm going to not answer that. But maybe Victor, you can answer it later with your fingers.
Yeah, if you ping me, I can give you my 2 cents about that.
So to close the show, each of y'all get a couple sentences to sum up your technology and why should it be picked. But you know what? In this case, our choices that we're being given are a little hairier because we have 2 technologies, but then we also have the choice of deploying it on the cloud versus deploying it. So before you pitch why vote for your technology, I like Victor from you to really specify what our choices are when we're voting.
So the choices, and actually it's already in Twitter. Go to vFarsik over there. And there you go. So the 3 choices, right? One is to run it locally in your Kubernetes cluster using Helm. Choice number 2, locally in your Kubernetes cluster using Crossplane. And the third one is using one of the managed databases, AWS, Azure, or Google, using Crossplane. Now, if you choose that, there is still Helm there behind to package it with your application, but that's coming later, right? So 3 choices: local Helm, local Crossplane, cloud Crossplane.
Okay. So with those 3 choices in mind, Andy, you go first and pitch your tech for us, please.
Sure, no problem. You're a developer. You want to be able to get resources and get your application deployed quickly. This is Helm, makes it really easy to package up all of the dependencies that you need, easily deploy it to any environment in any namespace that you own. No additional resources necessary. Simple. Couple clicks, couple commands, integrate with other tools, be productive, be successful.
Bing, bang, boom. Thank you so much, Andy. We appreciate your time and expertise. Bye.
Absolutely. Bye-bye.
All right, Dan. Some final words, please.
Yeah, absolutely. So in my mind, as a developer myself, applications, always the goal is to get them into a production environment and be able to have that flexibility then to continue to iterate them on the development setting as well. So I want to design my application, especially if there's no overhead in doing so, to be able to run in a development environment or in a production setting. So why not go ahead and start with that model from the beginning? And as you evolve and change over time, the tools are going to work with you the same way.
Excellent. Perfect. Thank you so much, Dan. See you at
Thanks,
KubeCon. Bye. There it is. We have 3 choices. Time to cast your vote. Make your voice heard. Let me get my vote. Vote.
Vote. Right away.
Do it now. So right now the voting poll is on Victor's Twitter handle, which is on the screen right there. So go check Victor out on Twitter. Vote, and we'll be announcing not the winner, but the chosen technology on next week's episode, and we'll implement the chosen technology too.
So you're saying there is no winner in this in those episodes, right?
There is no winner, just what y'all choose.
That means everybody's loser. Or, I'm not sure.
It's a glass half full situation. And join us next week. Thank you so much for the wonderful questions, and feel free in the comments to put questions if you're watching the recorded version, and we'll try to get to those. And next week, we'll be talking about database schema and how to manage that as part of our development environments. And we'll have a couple choices there. Any last words, Victor?
No, just go vote. See you next week, and we'll figure out how to make that, because running a database itself is useless, right? How can we create the schema and everything else required in that database? That's the next one.
Next one. Now we need someone with a cane to pull us off and strike a gong.
And there will be a gong, exactly. So come for the gong. I bought the first one on the list. I don't know whether I'm getting this size or I'm getting full size. I know nothing about it.
I hope you have to stand up to use it.
I did not check anything, really. Not even the price. I don't know, maybe. So I was in a hurry. First result in Amazon. That's what you're getting.
Excellent. All right. This has been wicked fun. I'm super excited to talk to y'all next week. Goodbye.